Hello everyone, welcome to SmartMate Tutorials. In today's video, we are going to learn how to use pre-commit with a Java code base. First, what is pre-commit? Pre-commit is a tool that runs predefined checks whenever we make changes to our code base locally. So, the pre-commit will run the checks before we are able to run the git commit command, or as we are running the git commit command. This checks includes ensuring that we do not commit to the wrong branch. For example, the protected branches like master, testing, production, and so on. If it would be a Java code base, as is the case in this tutorial, some of the checks that pre-commit can run also includes things like ensuring we have the right code format, ensuring that there are no unused imports, ensuring that there are no large files, right? And so on and so forth. So that's what pre-commit does. So in essence, if you look at it, pre-commit helps us to maintain the coding standard across for a particular code base, especially when you are working as a team, right? Where there are multiple people, multiple engineers working on the same code base. That is what pre-commit helps us with. Now, uh, pre-commit itself is a framework, right? It enables anyone to develop hooks or these checks that can then be plugged into the framework at the code base level. For this tutorial, we are going to consider two different hooks, right? The default pre-commit hooks, this one comes with the pre-commit hook framework itself. And then we're also going to consider pre-commit for J, which also enable us to run all those beautiful checks for a Java code base, right? So now, we first need to set up our local machine. To set up our local machine, pre-commit itself was built with Python, so it requires a Python runtime environment. I have Python version 3 on my local machine installed. It's recommended that you use Python version 3, or as is the latest one. So I'm just going to quickly run py3 install pre-commit to my local machine. And once that is done, I can confirm the installation by running pre-commit version. Yeah, now that shows that I have pre-commit version 4.0.1. For this tutorial, we are going to be adding pre-commit to a code base, the code base of an open source library that I created a while back. The open source library is called Request Validator. It helps to validate incoming requests for Java web applications. For example, let's say you have a request data payload like this, right? You can specify rules based on the request. First name is required, last name is required, cannot be more than 250 characters, email is required, cannot be more than 250, and must be a valid email address, and so on and so forth, right? So that's what the request validator library helps us to do. So what we are going to do is we will add pre-commits to the code base so that when other contributors wants to contribute to the code base, we make sure that the coding standard is the same across board. So I'm going to go ahead and open the code base in my IDE. All right. So now that I have the code base opened in my IDE, right? So to enable pre-commit for a single code base, the first thing we need to do is to add a file called precommit.precommit config YAML file, right? So it's a YAML file, so I'm just going to go ahead and create it. .precommit config.yaml file. So it's a YAML file, and this YAML file is the one that will contain all the hooks that we want to run for our code base, right? All the hooks that we want to apply. It will also describe where to get those hooks from, that is the repo for those hooks. So the config file typically will contain items like this. You can see here what it contains is repos, and then for repo we have defined this repo, which is pre-commit hooks, and then we have defined some of the hooks that that we want to apply, right? So going by this, if we go to, so what we are saying here is that we want this particular pre-commit hook offers the following checks. Right, there is check YAML, which we check all every time we want to commit our code base. It will check all the YAML files and the code base and make sure that they are formatted properly. There is the end of file fixer, which will ensure that there is always a new line. Every file ends with a new line, right? And then there is the no commit to branch, which is very important, right? So let's say we are working on a new feature and we forgot to check out, right, to a feature branch, right? So, and want to commit, at that point, this check is going to stop us from committing, because to make sure that so as you to protect the branches that are designated as protected, usually master, testing, production, and other such branches. All right. Now that we have this pre-commit config file in the repo, the next thing we need to now do is to come to the code base, right? This is the working directory of the project, right, of the code base, and then I'm going to run pre-commit install. So pre-commit install basically is going to install all the hooks that we have defined here in this for this particular code base, right? As you can see here, it added them to the Git hooks, right? So that's it. So then once we do this, by the way, it's a good time to speak about how pre-commit works. Pre-commit works basically by attaching itself to the Git lifecycle, right? So it intercepts and then listens to the Git lifecycle, and then it's able to run the checks right before the Git command is executed, right? So that's why the name is called pre-commit, right? Before you commit. So in this case, now that we've installed it, the next thing we need to do is that we need to try and add it, add all, right? We need to try and commit. So I'm just going to do git add all, git status. You see, this is the only thing. I will say git commit. I will say added pre-commit file. So once we do that for the first time, it's going to initialize pre-commit, initialize the environment for the hooks, and then it will run the checks. Now you can see it has run the checks, right? The check YAML passed, but the fixed end of file did not pass. But the interesting thing about the fixed end of file is that it's going to modify all the files, right? You know, but now you can see the interesting one, the no commit to branch. You see, I'm on branch master now. And then you can see already here, this guy is failing because of that. First, I will check out to a new branch. Let's check out F1B feature slash pre-commit, right? So that we can pass this, and then I will do git add all again, and then I will try to commit afresh. Now you can see the pre-commit has passed. So if we go to the home page of these hooks, there are other hooks that we can benefit or that it offers. You can see it offers check added large files, which we have already added, and a lot of other things, right? Check YAML, check XML, debug statement, destroy symlink, detect private key. These are very good checks that we have, right? But we can also see quickly that it have trailing white space. This is another common mistakes that you typically have in code base. So we can add that as well. So for us to activate this, we just need to come to we need to go to our code base, and then we need to edit. We need to add the ID here. We call it trailing white space. I believe that is correct. Okay, it's just one word. So we have trailing white space. That's it, right? So with this, we can add, and then we can try to commit again, and then our commit will still check. But now you can see that this one is working because there are no trailing white space in any of our code base, and then so therefore our code has been committed, right? So what we've done so far is to run pre-commit using the git Git lifecycle, right? Add the Git lifecycle. But if you notice, you will notice that the Git lifecycle will only work on the files that we have changed. So if you are adding pre-commit to a code base for the very first time, it's advisable that you run pre-commit, run all files. This will run all these checks against every single file in this particular code base. And as you can see, there are quite some changes that this guy has done. For example, ending of file, this guy has fixed. This one is self-resolving, it's automatically fixing. So it will detect and fix. So it has added a white space to ending of file. So if I just come and open one of these, so if you open one of these now, you see that it has added this, make sure that the file is having a proper ending. No? So I'm just going to do add all, and then and then you can change the message to something like pre-commit fixes, right? So we can just leave that, and boom, we are good to go, right? So now if we run pre-commit all files, you can see that everything is passing. So this is a very good baseline that you can have. There are some times that we don't want to run all files at the same time. You can run for specific file. Let's say I want to run pre-commit for just this class, right? I can come here, copy the path here, and say pre-commit run, and then I will give you the file and then the path to the file, and then it will run to just check for this single file, right? That's it. So that's the basics of the pre-commit hooks. What we are going to do next is to add another interesting hook, which is the pre-commit for J. Pre-commit for J is a hook that gives us access to the check style library. Now, what is the check style library? The check style library here, as you can see here, that's available here, it's a tool, a development tool, right, that ensures that whatever code we write as Java engineers, they conform to a coding standard. How does it work? It's a jar file that expects an XML file. The XML file contains the coding standard. So whenever we execute, we invoke the jar file, passing in the XML file and passing in the source code. It will validate to make sure that all the source code conform to defined or predefined coding standards, right? So that's what check style is, right? So pre-commit for J, as we have seen here, is a library that is written in Ruby, is written with Ruby. So what it does is specifically is that it plugs in check style into the pre-commit framework, right? How does it work? So for us to use this, we need to go back to our code base. Then we need to add the hook. Once we've added the hook, let me just quickly format this. It's lacking some tab. So once we've added the pre-commit for J hook, we are also now we have to now specify the coding standards that we want to adhere to in an XML file. If we quickly go back to the check style page, you see that they support majorly two different styles. There is Google style, and then there is Sun style. Sun Microsystem is it's a very old company that owns that originally created, where originally, James Gosling worked on Java rather, sorry. So we are going to use Google style, Java style, and then we can get the file here. So this is the XML file. What we do is we just copy the whole thing, and then we bring it to our code base, right? We had it, say new file. We are going to call it Google checks.xml, and then we paste, right? So then we now we pass this Google checks as an argument to the pre-commit for JHook, right? So then what we've also done here is that we've excluded test, but I don't think we need to do that. Can leave that out. So now that we've passed the Google checks.xml to the pre-commit for JHook, right? So the Google check.xml, the first thing we need by default, it tries to report all the errors as warning. So we are going to put it as error. Once we do that, then we can now try to commit again, right? We can now try to commit again. We do git hash, git commit, -m, added Google checks.xml. So we can see that we still fixed the header file. So just gonna do that again. Now we can see everything passed. But hey, everything passing, does it mean that we have our code base is up to date? Not really, or not necessarily. So what we are going to do is we are going to run pre-commit run all files. We are going to run it for all files and see what's going on. Oh, we call it Google checks. Okay. Let's call it Google checks. Let's quickly fix that. So we'll run it again for all files, and you can see check stuff has run. And now it detects 828 errors with our code bases. You can see different type of errors. For example, avoiding star import. If you click on this, you can see that we have used star import in this place. Extra separation here, and so on and so forth, right? So one thing again to note is that what we are going to do is that we are going to adjust this Google checks to suit our style, our coding standard. So we don't have to necessarily adhere to everything verbatim. So what I will do is I will add some suppressions, right? I will add suppressions here so that I will have a suppression filter here. So the suppression filter is going to ignore every error that has to do with custom import order, missing Java doc type, missing Java doc on the method, right, for all Java cases. Finally, I will change the indentation as well. Indentation here. I'm going to replace this with one that I've already pre-configured. For example, you can see that we've changed the offset, the brace adjustments, and all of this, right? We've changed all of those values to what we want, right? And then finally, there is the line length. By default, the line length allowed is 100 characters. So we're just going to change that to 130 to suit our own need, right? We run it again. We run the checks again, run all files. And now you can see we are left with half of the errors are gone. If you're adding pre-commit to a code base from scratch, it is advisable that you fix all the errors once and for all, right? But in some scenarios where you can't fix all the errors, it's okay. You can still commit your code base, right? We can still commit, for example, and it won't still detect all the errors. However, every time one of these files change, it will require that we correct them. For example, I'm just going to make a minor change to say this class, for example. I'm going to say change this to capital T, right? So if I now try to commit, right, say updated comments, as you can see, it will run the checks, and then now it will detect all the challenges that are present with this rules.java, right? And then I'm just going to quickly format that. You can say here should be preceded with an empty line. If you read what this means, so what it is saying is this, right? We can just have that, and boom, and like that, this should work. You can see it has passed. So that means this particular file is okay. So this is the best approach, because once you had it, as the team makes changes to each file over time, you eventually get to a point where you get to fix all the files and then you bring them to the correct state to match up with the coding standard. This is especially useful if you're adding them to an existing code base. If you are adding them to a new code base that has not, that is not in production or something, so of course, endeavor to fix all the checks once and for all. Going by CI/CD principle, having the checks on the developer's machine is not sufficient. What if the engineer forgot to run pre-commit install after cloning the code base, right? You remember, if you don't run pre-commit install, the pre-commit checks will not be executed. What we need to do next is to add the pre-commit checks as part of our CI/CD pipeline. So once we do that, we are guaranteed that every time any new code changes going forward, there will be pre-commit job that will run, and we make sure that what the changes that is the engineer is trying to push to production is in alignment with the predefined coding standard. Now, for this particular code base request validator, there exists a Circle CI pipeline already. So what we're going to do is just to modify this CI/CD pipeline to include running checks for pre-commit. So what we've done here is simply to add a couple of more steps, right? So we add the step to install Ruby, the steps to install Python, right? The reason why we have to install Ruby is because this pre-commit for J is written in Ruby and requires Ruby environment to run, right? So we have Ruby, we have the steps to install all of these ones. Actually, we don't need this now. And then we now install pre-commit. And this is the interesting part. We have an if condition here that makes sure that we can either run pre-commit all files, or we run pre-commit for only the changed files, right? Remember, and so that's what we want. And again, this is very useful, especially when you are trying to add pre-commit to an existing code base. It's very important that you don't create a bottleneck, right? And one of the ways we do that is to make sure that we are only running pre-commit for files that have changed, so that way the engineer that is creating the merge request, we only have to fix the files that they have modified, right? Which is okay. So that's what we are going to do. So right now we can commit these changes, right? We can say updated CI, Circle CI. Okay, still the end of files again. And then we can do this, updated Circle CI, everything has passed. And then now we can push our code which changes. Right, now that we've pushed, we are going to create a new merge request and see how the job will run on the UI. Okay, so we have feature pre-commit. We want to merge into master. We are just going to create a pull request. And then we wait for the job to run. And now that the job is running, the Circle CI job is running, we can go to details to view the details of the job. You can see still spinning up environment. Just give it a couple of seconds for it to run. And that's it. You can see that the job has completed running and it's successful. If you go back to the merge request or pull request, we can see that it's yeah, CI/CD has passed successfully. And that's about it. So if we go back to the code base, a few things to note. If we go back to the code base, is that for the CI/CD pipeline, we actually define a variable here that helps us to determine if we are to run pre-commit for all files or only for the change files, right? The advantage is that if you're adding to a legacy app to an existing code base, as I've said, you can set this to false as we have it now. And then once you are sure that all the changes have been, corrected, all the violations have been fixed, then finally you can then set it to true, which will run it against all the files all the time. But I think it's actually good to just keep it to run for only change files, to also because of the speed of the pipeline. And that's where we'll stop for this tutorial. Thank you for watching. Please subscribe to my YouTube channel and share this video in your network. Right. If you have questions, please ask in the comments. The link to the complete source code will be available in the description. Happy coding.